Hello, everyone. Good morning, afternoon, evening. Dear authors and invited guests, welcome to Technical Session 7G. Myself, Priyanshi Goyal, and this session would be moderated by me. On behalf of Global Knowledge Research Foundation and GR Scholastic LLP, it is my great pleasure to welcome you to the 9th International Conference on Information and Communication Technology for Intelligent Systems, ICTIS 2025, Bangkok, Thailand. The 9th edition of the conference is being organized in a hybrid mode. The physical event was held yesterday in Bangkok, Thailand, and the virtual event is being held through Zoom today and tomorrow, that is 5th and 6th of April 2025. I hope you will enjoy the knowledgeable and interactive sessions throughout the day. In this session, we have 10 presentations. Each presenter will be given 10 minutes for the presentations and 2 minutes for question and answers. On 9 minutes, I'll raise a gentle reminder. It's a kind request to all the participants to kindly adhere to the time limit. There's another request to all the participants that you all stay connected with us till the closing remarks. If you have any query or update, then you can write it to me in chat box. Just before we start the session, I would like to introduce you all to the chair for this session, Dr. Vishwajit Thakur. Dr. Vishwajit Thakur is a professor at Indrashil University, Mahesana, India. He has authored and co-authored research papers in national and international journals. He has published 3 books. His areas of specialization are digital logic design, computer organization, image processing, robotics, and control. I would now like to invite Dr. Vishwajit to kindly address the session and deliver the welcoming remark and set the tone for the session.
Very good afternoon to all of you. Uh, it is nice to see all of you here on the 9th edition of the ICTIS. And as all of you are presenting your research work to this esteemed conference, I hope that all of you will present it well. And I wish that whatever is happening in the intelligent systems and the role of information and communication technology is increasing in leaps and bounds. And you can see that it is used everywhere. And now with the advancement in the AI and cybersecurity, ICT has to be very careful in securing their tools, their technologies, their devices, and their systems. So it is very important that information and communication technology, which is now at the heart of all the branch of engineering, is is available to our mankind for the benefit, be it agriculture, be it healthcare, be it transportation, be it aerospace, defense, space, any sector. So ICT is playing a very crucial role, including navigation and controls as well. So new technology tools and algorithms which are coming up into the different sessions, in the different areas are going to help the mankind in a different way. So I wish you all the best for your presentations, and thank you very much.
Thank you so much, sir. Thank you so much for joining us. Now, without further ado, I would like to start with the session for today. First up, I would like to invite Ananda Minachi to kindly present a paper titled A Comparative Analysis of Prominent Operating Systems, Windows, Android, Linux, and Others. Do we have you here with us, Ananda? Anisha, also please change the screen. Do we have you here with us, Ananda?
Yes, ma'am.
You are not audible clearly.
Oh, I can't share my presentation.
Yes, just a second. We'll
Okay.
stop presenting. Yes, you can share now. Your screen is visible.
Ma'am, is it visible?
Yes, it's visible. Please put it in presentation mode.
Then go to slideshow and then
Yeah.
Wait, ma'am. 1 minute, ma'am. Ma'am, is it
Yes.
visible?
Yes, it's visible. You may start.
Okay. Good evening, sir. I am Anand Meenakshi. I am a third year computer science student in VIT Vellore, India. Uh, this is my first conference paper. I am very excited to share my presentation on comparative analysis of pro-dominant operating system, that is Windows, Android, and Linux, and others also. This work was done along with Deeva ma'am and Saravana Kumar sir. They are my professors. Now I starting my presentation, and these are the objectives of my presentations, and I will explain this in following slides. I start with the introduction. Today's world's operating system plays a crucial role in everyone's life, and it enables the interaction between the users and the hardware. And in other ways, we say operating system acts as the backbone of computing devices. And in my research, Android was the first position, and it's dominate the mobile market because of its user-friendly environment and extensive of ecosystem. And second one is Windows. This whole second place in my research, and it is all used widely used for both enterprise and personal computing related things. It is mainly used in desktop related things. And third operating system is Linux, and that is used for ethical hacking related things, and it is also used for servers development related things, and other OSs are used for some other purposes. So in my research, I mainly focus on three operating system, that is Android, Windows, and Linux. And this is my first operating system, that is Android. It is a leader, and Android is currently most usable operating system because of its user-friendly environment. It provides a flexible and a securable environment to their users. That's why it holds first place. And real-time example is Samsung. Samsung will provides a efficient usage of their environment, and it provides a flexible and a securable future to their users. That's why it's leading. Second, this is the usage percentage of Android. 40% user is used the Androids because of its versatile and open source mobile operating system features, and it supports a wide range of operating systems and a wide range of devices also, and that is smartphones, tablets, and smart TVs, and etc. And second one is Windows operating system. It is mainly used in desktop applications, and it provides the graphical interface to their users, and it's also user friendly, and it provides a high security to their users, and that's why it is used by 30% of people, and it provides a secure environment. It is mainly used in corporate related things, and in that it holds a second position. And third operating system is Linux. Linux is a open source and customizable operating system. User can modify and use it freely for their use, and it is a securable and stable operating system, and it's widely used for servers and development related things. And one of the real-time example is Kali Linux, that is used for ethical hacking related things. And this is the usage percentage of Linux. So 3% is used by user, and it is open source, highly customizable, and it is also support the multitasking and multi-users access. And these are the other OSs. In my research, I already said in my research, I mainly focus on three OSs. So I plan to expand this research. In my future research work, I focus on this operating system also. I just define a few things in my papers and in my presentation also. So OS X and BlackBerry and Symbian, this is used for basal market environment related things. And iOS is used for mobile applications, and one of the examples is iPhones and iPads. And third one is PlayStation and other OSs. That is mainly used for gaming related things. It is mainly focus on gaming, and these are the operating system usages and their efficiency. And Windows, it holds 30% users, and Android 40%, and other OSs are followed. I will explain and Windows and Android Linux here. In my future work, I will definitely incorporate these things. And this is a different comparison chart. This is also same represent and the same thing. That is 40% Android and 30% Windows, and the others are followed. And this is a pie chart representation. This are also the dark purple color line represent the Android. That's is the highest one, and others are followed. And this is my algorithm. I collected the small data set from Googles, and I use Python code to implement these things. And I explore lot of OS trends, and I finally provide the confusion matrix. And I explore lot of usage and efficiency related charts, and finally I concluded that that's my overall and that's my algorithm also. And next one is literature reviews. I collected the literature reviews from Google Scholars and reviewed lot of papers. These are the few papers from that. First one is Fedas and the Seger's paper. It represents the boot process and OS futures. And second one is Tangavel and others. It represents the OS strengths and the security. And this paper is very good for me because it's explore the different OS strengths and the different security features. So I learned lot of things from this paper. So third one is Cheng L. This paper mainly speak about the Android versus iPhone usage and the iPhone futures. And the fourth and fifth are same thing only. It's speak about the Windows and the Linux performance and the security. Main differences, fourth paper is speak about the performance, and fifth one is speak about the security. So these are the five papers. I learned lot of things from that. And finally, I concluded that Android dominates the mobile applications, and Windows is followed, and it leads the desktop applications, and Linux is mainly used for server related things. And each operating system provides their unique feature and unique platform to their users. So these operating system definitely dominate the futures. And nowadays many operating systems are existing, but we need to choose which operating system is more suitable for our current working environment. And most of us don't know about this. So that is the challenge of users. So in my paper I clearly define that, so it will help the future generation also. And my paper is very simple and efficient for analyzing these three things, that is Android, Windows, and uh,
This is a gentle
Linux.
1 minute reminder.
Okay, okay. So my paper clearly explains this, and it helps the user to choose the right OS for the right purpose. That's my overall conclusion. So
Thank you so
that's
much.
okay, ma'am.
Are there any questions?
Ah,
So I have one question, two questions typically.
ah, okay, sir.
Ananda, can you explain what are the main functions of operating system?
Uh, It is mainly used for the operating systems are it is 1 minute, sir. It is mainly used for different purpose, sir, operating system. It is used in education related things and also business related things. So we need to
No,
choose.
no, what I'm asking is,
Uh,
what are the main functions performed by operating system?
it handle all the computer related functions, sir. It's like
Like it manages
it is a
process, it manages IO, it manages memory, it manages file. These are
yes,
the functions, right?
yes,
Okay.
yes,
Now
yes,
tell
sir.
me which operating system is secure out of these three, most safe and secure.
I that is Android, sir. The in my analysis, Android is top, and that is a very secure and scalable operating system, sir. In future, it may differ, sir, because OS trends are changing year to year. So in future it might change, but now current analysis is Android is a very secure and say scalable operating system, sir.
Okay. Thank
Okay, sir. Sir, do you have any other questions?
you. Thank you.
Oh, okay, sir. Thank you.
Thank you so much.
Okay. Thank you.
Um, Moving forward, I would like to invite to Hang Nguyen to kindly present a paper titled Computational Modeling of Dielectrophoretic Cell Separation in a Flow Focusing Microfluidic Chip with Planar Interdigitated Electrodes. Do we have you here with us, ma'am?
On behalf of Miss Hang, she's currently have health issue. I'm the second author, and I will present the paper.
Sure, sir. Just before presenting, kindly introduce yourself and then you can present the paper.
I'm Ronald Chung, and I'm the second author of the paper, and I will present on behalf of Miss Hang.
All right, all right. Your screen is visible. You may start.
Yes, so good afternoon, everyone. So today I will present the computational modeling of dielectrophoresis. This separation in the flow focusing microfluidic chip planar integrated electrodes. Here's our contents, and to begin with, the cancer is a disease that can start in almost any organ or tissue in the body where abnormal cells grow uncontrollably, go beyond the unusual boundaries to invade adjoining parts of the bodies and spread to other organs. Cancer metastasis is the formation and development of secondary tumors in another part of the body from the original tumor site, which is 90% of cancer patient death caused by metastasis. So CDC stands for circulating tumor cells emerge from primary cancer cell. In other words, CDCs infiltrate the peripheral blood circulating systems. So compared with primary cell, cancer cells, CDCs exhibits a higher frequency of mutations, accumulation, and a greater severity within genetic alteration due to somatic cell mutations and acquisitions of extra circulatory system properties. Due to the low quantity of circulating tumor cells present in blood samples, it's challenging to separate and detect them effectively. So method in detecting the CDC is dielectrophoresis. It's a technique that have received tremendous attention from researchers, and Electrophoresis is the method which capture and separates cells based on different dielectric properties and cell size. Here are some related work. In recent years, a variety of micro devices using DEP for cell separations have been developed. So there was a sidewall electrodes with different electrode designs were used for separations with high efficacy, much complex fabricants process. And in our previous work, we have numerical studies about the top and bottom facing electrodes, enabling to separate various kind of particles, but really much complex fabrication process. So we have proposed a microfluidic system to separate CCs and white cell based on the depth effect created by flow focusing microfluidic designs. So inlets, there are 3 inlets for the box sample and box solutions, and separation region containing electrode array for non-uniform electric field generations and outlets for CDTs. Also the white cells. So the electrodes consist of 2 alternate arrays. Each array includes 5 planar electrodes. Positive electrodes is placed lower, while ground electrodes is placed on upper. The flow focusing design is applied with alternate electrode array, optimized cellular positioning within the depth active regions, facilitating efficient separation based on the dielectric properties. So the depth force exerted on each cell size are different because of distinguishable cell size and electricity properties. So the different cell charge actually applied on the microfluidic chip. Here's the theory of the microfluidic chip. The major force applied on cells are hydrodynamic force and electrophoresis force. So in the microfluidic system, laminar flow corresponds to flow with small Reynolds number, and the drag force is defined here, where as can be seen, the drag force was directly proportional to the cell size and dielectric properties as the real part of Gaussian motility, the real of K omega, and the Laplacian of electric field strength. The net force is based on Newton's second law, where the drag force plus net force is equal to cell's accelerations. Also, our simulation is generated by console multiphysics. The cell's characteristics is shown in the table here, where the white cell has the largest diameter, and the depth force on the white cell was the largest because of its higher dielectric properties. Our simulations are based on the single cell model with an equivalent permittivity is assumed for the particle in terms of complex permittivity of the core paint pink and the shell paint blue in the model. So here's our results. This is the electric field norm in the cross section of microchannel. I can be seen the area to electrode print red and orange. The greater the electric potential and hence the higher electric field. The further area to the electrode, the faster the leads to the inferior of electric potentials. Moreover, we have investigated the phenomena whether applied depth force or not. Results has shown that without depth force, all of the shells migrate in the same trajectory as the pressure of the buffer flow pushes them against the wall. And finally, we have some parametric research. Under the optimal conditions with AC of 3.5 volts at 10 kilohertz, velocity at the side inlets and central inlets is 350 and 200 micrometers per second respectively. The separation efficiency for AT29 and WBCs was notable for the former by 86.67% and the latter by 84%. So we have some parametric research include with outline voltage magnitude and velocity of the side inlets. So at the voltage aspect, we apply the voltage from 2.5 volts to 4.5 volts with the 0.5 steps. This shows that the higher the voltage applied on the higher depth force leads to more deflected cell sectors, but they can might be harmful to cells. So at the 3.5 volts, the AT29 reached the highest separation efficiency with approximately with 86%. So another impact is that the noticeable is the velocity of the side inlets. So the blood sample velocity is fixed at 200 micrometer per second. Here we change the buffer flow velocity to determine the trajectory of the cells. So the higher buffer solution is, so the greater the drag force flow acts on particles. And at the velocity of 350 micrometers, the highest separation efficiency has reached. So in conclusions, a novel depth-based microfluidic chip was proposed to separate 8029 tumor cells and fibrous cells. Numerical analysis was used to verify the performance of the biochip design and optimize. This design facilitates the reduction of position dependence in the cell in the channel and complexity of fabrications. The proposed system offers numerous advantages such as compact size, low voltage, high efficiency, non-invasiveness, and label-free manner. So in the next phase, our research group plan to conduct the experiments as soon as possible. So thank you for listening.
Thank you so much. Are there any questions?
So thank you for your nice presentation. I have one question. Did you observe any other field other than electric field when you are designing biochip?
So this experiment has based on our previous work, but this method is way more easier to fabricate. So we have experiment numerical first, and then we will experiment later.
No, what I am saying is, did you observe any other field other than electric field that you applied?
Can you repeat the question?
Did you observe any other field that is biological field or field from cells, something which you could observe?
This is the numerical studies and the.
So what sir is trying to ask is, did you observe any other field
Field?
in sir, what was the question?
Yeah, did he observe any other field other than electric field during his experiment?
Okay, so sir is asking, did you observe any other field other than electric field during your observations? Like a biological field or something?
Fields or something. Well, I think that there's only electric fields because the electricity is from the electrodes, and only the velocity fields that we have conducted in.
Okay, no problem. Thank you. Okay.
Okay.
Thank you.
Thank you. Thank you for presenting.
Thank you.
Moving forward, I invite Sriram Suresh to kindly present his paper titled Early Detection of Parkinson's Disease Using Machine Learning, a comparative study of multimodal data integration. Do we have you here with us, Sriram? Is anyone else from the team present? Since no one is responding, we'll be moving forward. I request Ayush Sinha to kindly present his paper titled Enhancing Hindi Language OCR, a Deep Learning Approach. Do we have you here with us, Ayush?
Yes, ma'am, I'm here. Can I share
All
my
right.
screen now?
Yes, please. Yes, your screen is visible. You may start.
Just a second. Okay. Yeah, my screen is visible, right?
Yes.
Okay. Good evening, everyone. My name is Ayush, and I would like to thank the organizers of ICTIS for giving me the chance to present my work. The topic of my paper is enhancing Hindi language OCR, a deep learning approach. The co-authors of the paper are Yuvraj Natarajan sir, under whom we have done the research work, and two of my fellow college mates, Satvik Tripathi and Kaushik Telapula. I'll be presenting the paper on behalf of the entire team. So the contents would be introduction to what the OCR technology is and why are we performing the OCR efficient models for the Hindi language, then looking at the background of how the OCR has developed throughout the years, moving on to the data set which we have used for our models, and then the main part of the methodologies, which consist of different deep learning models which we have implemented, and we'll look at the results and conclusions and few of the future works. So optical character recognition is everyone would know it is a process which converts an image of a text to a machine readable text format. So it is a very common feature nowadays, but apart from English and some simple languages, other complex languages face difficulties while performing OCR on various fonts. So why did we choose Hindi language? The script, which is known as the Devanagari script, is a very complex character set, which includes a lot of diacritical marks as well. And the Hindi language does not have a structured and a complete data set as such, which can be efficiently used for training models to recognize characters. Despite it being the third most spoken language in the world, we do not have any indigenous uh, complete system which can very efficiently detect the OCR text. So early systems would rely on template matching and rule-based algorithms to recognize fixed character sets, making them very unsuitable for diverse fonts and styles. So with the advancements in computational power, all those feature extraction methods which were identified as edges, curves, and intersection dominated the field. But all of these features struggle with the noise, distortions, and handwriting variations. Uh, Subsequently, the rise of artificial intelligence techniques, including the machine learning and advanced neural networks, transformed the OCR technology. Neural networks, especially CNNs, enabled automated learning of hierarchical character representations, which eliminated the requirement for manual feature engineering. So this method allowed OCR systems to handle diverse fonts, styles, and challenging text conditions. Despite these advancements, OCR for scripts like Hindi are still a challenge. So the dataset which we used is known as the Shabd dataset, which is available on Kaggle, and it has a total it contains a total of 304,150 grayscale images, which are divided into, it has actually two variations of data, which is grayscale and inverted grayscale. For our purposes, we have used the inverted grayscale data sets. As you can see, there are some sample images from the data set, and each of the characters from the Hindi language has 792 images, uh, labeled and unlabeled mixed. Each of the images have been already pre-processed to a 32 by 32 pixel width. And I would like to point out that the original data set has 32 by 32, that is 1024 pixel values, rather than the images itself. So initially, when we started our OCR models, we used the direct CSV format data, which were the pixel values which ranged from 0 to 254. So, but then we converted all those pixel values to images and trained some deep learning models to test how does it work. So basically, we worked upon three different methodologies or three different models. The initial model was a sequential neural network model, which we used for the pixel values data set. It's a sequential neural network is a fully connected model. It has an input layer of size 1024, and which is followed by three dense layer with 512, 256, and then 128 neurons respectively. Sorry. Yeah. And moving on to the next the LSTM model. In the LSTM model, we took the LSTM model as a development from the neural network model, where the input data is as defined as 32 or 32 matrix, and it is processed by two stacked LSTM layers. Each layer has 64 units to capture the temporal dependencies, which is the primary objective of using an LSTM. And after passing through the LSTM layers, the output flows into a dense layer with 128 neurons. And we use the ReLU activation for feature extraction. And we consider a 30% dropout layer to minimize the overfitting which might be observed. The third and the most efficient model as observed by us is the CNN model with the batch normalization. So the layer structure was two convolution 2D layers which with ReLU activation, and we used batch normalization after each convolutional layer to stabilize the learning process. To reduce dimensionality, we used max pooling layers. Here also, we used a 30% dropout layer, and the classification output is generated using a softmax activation out. So yeah, now looking at the results of each of these models, we could see in the sequential neural network model, the training accuracy reached 0.95, and while the validation accuracy kind of stopped plateaued at 0.9. We can see a gap between the validation accuracy and training accuracy. So the orange line, which is the validation accuracy, starts higher than the training accuracy at about 0.6 and increases more gradually compared to the training accuracy. So a model performance was it demonstrated effective learning with training and validation accuracies improving consistently over the epochs. But the model generalizes well to unseen data, but does not achieve the same as we can see between the difference of training and validation accuracy. There might be a possibility of overfitting in this model, so which can be observed by the gap between the validation and training accuracy. Convolutional neural network model with batch normalization. The results of LSTM, it exhibited a very positive near perfect training and reached almost a validation accuracy of 1 by epoch 5. And the architecture demonstrated a strong adaptability to sequential patterns in the data. And when coming to CNN model with batch normalization, we can see that the speed, the model performance, that there's a rapid rise in both training and the validation accuracies, that it tells us that the model learns very quickly, potentially due to the tasks, maybe due to the simplicity or the model's strength. which are normally the cases. But here we can observe, due to the previous two models, this is just because of the model's strength that it has achieved a high accuracy. So this is the conclusion, where all the three models did achieve a very high accuracy, but out of all these three, the CNN with batch normalization achieved the highest. And so the future research, like what we believe from the Hindi language, Hindi OCR models have performed better than expectations. And the project began with a goal to provide accurate and efficient OCR models, which can be used by multiple industries. So the outcomes of this work should have profound implications for education, research, and government services. Future research can also build upon these advancements by exploring hybrid models, integrating transfer learning, and developing real-time OCR systems. We are hoping that the training data set would be expanded in the future times, and also multilingual capabilities can be added, and developing digitization is document digitization and education accessibility. There are many domains in which the applications of Hindi and multilingual OCR can be used. For an example, in India, we see a huge transition from paperwork to a digital work. So there is a continuous digitization going on, and to have lots of documents in regional languages or Hindi language, it is quite difficult to. It's a big problem to overcome right now. So we are hoping in future we can build upon complete application which can help us in all sorts of digitization of documents. And thank you. That was my presentation.
Thank you, Ayush. Are there any questions? Are there any questions? All right. Moving forward, I would like to invite Shreya Mohad to kindly present her paper titled Ensemble Learning for Autism Diagnosis, a High Accuracy Machine Learning Approach. Do we have you here with us, Shreya?
Yeah, hello, I am here.
Yes, just a second, I'll stop presenting.
Yeah.
Yes, please go ahead.
Yeah. Is my screen visible?
Yes, wait. Yes, your screen is visible.
Okay.
You may start.
Okay, thank you. So good evening, sir, and everyone present here. I'm Shreya Mohol, and I'm a final year student pursuing BTech in computer engineering, and I'm from Pimpri Chinchwad College of Engineering. So our topic is autism detection using ensemble learning approaches. This work is done along with my three fellow teammates, namely Anushka, Manoj, and Harshali. And we have done this work under the guidance of Professor Shailesh Galande. He is my project guide. So let me start by telling you all what is autism. So autism or autism spectrum disorder, it is a neurodevelopmental disorder that affects how a person communicates, interacts socially, behaves, and learns. And the key characteristics of autism are social interaction difficulties. So the individual may have trouble understanding social cues, such as facial expressions or tone of voice. And he or she may also suffer from communication challenges. So delayed speech developments, or he or she may repeat phrases, which is also called as echolalia. And other characteristics include repetitive behaviors and routines. So this is our content. So the main motivation for conducting this research was early intervention, challenges in existing diagnosis, and we wanted to bridge the gap between healthcare and AI or machine learning algorithms to bring change in the real world. So autism is mainly diagnosed in toddlers, and the early it is diagnosed, the more effective the medical procedure gets. So we had that in mind while conducting this research. And the objectives are to develop an accurate and early detection model and improve the diagnostic accuracy and enhance the interpretability. Now the scope is as follows: early screening, integration with healthcare, scalability and accessibility. And the feasibility, it was feasible. Um, Data was highly available. Data-driven decision support was also there. And we also had a say in real-world implementations. So these are the hardware and software requirements. We mainly conducted this project on Google Colab and used Python libraries such as NumPy, Pandas, Scikit-learn and all. And then we conducted literature survey. We have surveyed around 15 to 20 papers, but I have included the 5 most important papers here. These are the 3 and these are 2. So I'll give you a brief summary. These papers used LightGBM, XGBoost, CADBoost, extra trees classifiers, and they predicted an accuracy of around 94.72%, and we wanted to better it. So yeah, this is our proposed system. Firstly, we loaded the data set, then pre-processed it, and it is now split into training and testing in the ratio of 80:20. Then we checked if the data is balanced. Then if it is balanced, then we directly went to calculating the feature importance. And if it is not, then we did ADASIN, which is adaptive synthetic sampling, which basically does the following work. It generates synthetic values for the minority classes. So for example, our target value was uh, yes or no, I mean ASD, yes or no. So we had a minority of the yes classes. Therefore, we used ADASIN and it uh, sampled the yes classes. And then we used an ensemble of 3 following algorithms: XGBoost, LightGBM, and CADBoost. And then we used a voting classifier to finalize the model. And we used soft voting. Soft voting basically um, it averages the score of each of the of every algorithm, and then we evaluated the model. So our data set, it has around 1100 data points and 23 attributes. So the attributes are as follows: age of the person, gender of the person, jaundice, then autism family history, result, and then class. And then we have 10 columns, A1 to A10, which are questions, basic questions like do you have problem in communicating? Do you um, have the need to interact socially or not? Like that. And then these are the algorithms that we used: XGBoost, CADBoost, and LightGBM. We have basically assembled these 3 algorithms. So XGBoost, all the 3 algorithms are based on decision trees. XGBoost uses gradient descent. CADBoost CatBoost is basically dependent on categorical values for prediction, and LightGBM, it is an advanced um, gradient boosting algorithm, and it uses parallel computing, and we have done the ensemble of that. Now, turning on to complexity analysis, the overall time complexity of our model was big O of d into log n, where d is the maximum depth of the tree, and the space complexity is big O of k into d into n, where k is the number of boosting iterations, d is the maximum depth of the tree, and n is the number of samples. Now moving forward, we have created use case diagram and sequence diagram. So as you can see, here is our use case diagram. And here is our sequence diagram. Moving forward, these are the modules. So firstly, we pre-processed the data, then balanced it using ADASIN. Then we did model training and did hyperparameter tuning as well. And then ensemble integration of all the 3 models, then evaluation, and finally deployed the model. Now, what are the applications of our project? It will help in early screening. As I told you earlier, the earlier we diagnose autism, the more beneficial it is to treat medically, I'm saying. Then second is clinical support. And third is remote diagnosis. So most of the time, the people or the family, they are not able to access high high-end medical facilities, so they can conduct preliminary analysis using our project and then intervention planning. So the limitations that our system overcame are these are the papers that we referenced and what they did in their paper and how we overcame it. So basically, we used randomized search CV, we used ADASIN, we used SHAP, and we got even a higher accuracy from all these papers. Now here are the results. Our overall testing accuracy comes around 96.8% and training accuracy of 99.7%. And here is the matrix. So as you can see, it is a very balanced project because precision recall and F1 score are very high for both the classes. And then here is the precision recall curve. And yeah, this is the confusion matrix. As you can see, both the classes are here, autism, no autism. And the future work, what we are planning to do is we are trying to access or trying to communicate with the hospitals, and we are planning to use this project, use this product and system in hospitals to basically provide a preliminary step so that patients can diagnose it from their home, and if they are getting a higher score of uh, prediction, then they may visit the hospital and get treated. And we also visited autism centers near our college, and they were not I don't know, they were not agreeing to give us the data so easily. Therefore, we are planning to visit more centers and expand our data set and use real-time data set. We have used a data set from Kaggle now, and yeah, and conduct and integrate more algorithms in our system. And we are also planning to do CNN based on also planning to integrate CNN based on the neuro images and the images of the real patients. Yeah, thank you.
Yeah, Shreya, which kind of simulation tool have you used?
We have not used any simulation tool as of now, sir. We are only conducting it on code. Like we have used 3 machine learning algorithms. That's it for now. We are planning to integrate simulation tools in our future work.
Okay, do you know anything about TinyML?
I've heard about it, sir, but we have not planned to integrate it in here.
Okay, okay.
Do you have any suggestions, sir?
No, thank you. You can try these on TinyML platform. It is very useful.
Okay, fine. Thank you, sir.
Thank you so much. Yeah.
Thank you. Yeah.
Can you please stop presenting?
Yeah, just a minute.
Yes. Is my screen visible? Yes.
Can you have I stopped sharing?
I think yes. My screen is visible.
Yeah, fine. Thank you.
Okay. I would now like to invite Nivarthana to kindly present a paper titled Hybrid Approach for Optimizing Anti-Cancer Drug Combinations, a Comprehensive Review. Do we have you here with us?
Yes, I'm here.
All right, just a second. Yes. Please share your screen. Yes. You may present your screen.
Yeah, sure. Is my screen
Yes, it's
visible to
visible.
you?
You may start. Yes, it's
Okay.
visible. You may start.
Okay. Thank you. Good afternoon, everyone. I'm Danish Nivarthana. I'm finally an undergraduate at Faculty of Information Technology, University of Moratush, Sri Lanka. Today, I am honored to present our team research on hybrid approach for optimizing anti-cancer drug combinations. This is my research team, and this is the overview of our today's presentation. Let's begin with a brief introduction to provide contents for our research. Cancer is one of the most complex diseases due to its genetic heterogeneity. This means that the same treatment can have very different effect on different patients. Some respond well to a drug, while others develop resistance, making single drug therapies less effective in many cases. One of the most promising strategies in cancer treatment is combination therapy, where multiple drugs work together to target different molecular pathways. Compared to monotherapy, combination treatment often leads to better survival rates, improved therapeutic outcomes, lower dosage, and reduced resistance. However, identifying the most effective drug combination remains a major challenge, as there are millions of possible pairings, making experimental testing impractical due to the high cost and resource limitation. This is where machine learning and artificial intelligence come in. The ultimate aim of this research is to develop a hybrid approach to prioritize effective drug combinations and personalized cancer treatments, addressing key limitations in previous studies to enhance the precision of chemotherapy regimen. With the background in the mind, let's now explore some key studies in AI-driven combination optimization in more detail. Jackson et al. 2024 introduced mutation attention networks to extract hierarchical genetic representations, significantly enhancing classification accuracy in biomedical applications. Additionally, they implemented non-negative matrix factorization for mutation signature analysis, effectively identifying key mutational patterns in cancer genomics. This study lies in improving the interpretability of deep learning-based feature extraction methods and integrating multi-omic data to enhance the understanding of drug synergy to ensure the model generalization across diverse data sets. While existing data preprocessing methods such as normalization, missing value imputation, badge effect correction provide a foundation for multi-omics data analysis, there is a lack of comprehensive strategies that effectively integrate these preprocessing steps across multi-omic layers, especially in personalized cancer treatment. Additionally, while feature selection techniques like KS-test Baruta genetic algorithm help to identify relevant features, the challenge remains in their adaptability and scalability across diverse data sets. In recent advancement in graph-based machine learning has significantly improved cancer classification. Among the most promising research, Henry et al. 2024 developed a powerful multi-omics model to prostate cancer subtype prediction. By using graph attention network, this model assigned attention networks to gene interaction, achieving higher accuracy. However, it lacked dynamic profiling and did not incorporate drug synergy data, limiting its application in treatment optimization. Further, we found out that many research models depend on homogeneous graph representation, limiting their ability to capture complex biological interactions such as gene-protein relationships and dynamic molecular variations. Additionally, the exclusion of key omic layers reduces the accuracy and completeness of the prediction, hindering the clinical adaptability. Traditional machine learning algorithms such as support vector machine and random forest, along with the advanced deep learning models like deep synergy, have shown strong potential in prediction drug synergy. A recent study by Saho et al. 2023 introduces a machine learning framework that combines biomedical and molecular features derived from drugs and cancer cell line profiles. These integrated features are used to train predictive models capable of identifying drug combinations with potential synergy effect. Importantly, the predicted results undergo experimental validation, reinforcing their real-world relevance and therapeutic potential. One major challenge in synergy prediction lies in the use of single synergy metric. These metrics rely on different assumptions about drug interaction, leading to inconsistency in results. Furthermore, many existing models oversimplify the dosage-response relationship, which fail to capture how varying drug concentrations affect the synergy. This limits the identification of the most effective drug combination and dosage, ultimately impacting clinical decisions. Recent advances in personalized drug combination strategies have introduced several innovative approaches. For instance, Fat et al. 2024 combined AI-based drug response prediction with the dosage optimization for personalized chemotherapy. Their model improved treatment efficacy but did not address emerging drug resistance. And also, further work should focus on dynamic multi-omic profiling and real-time patient response tracking for better long-term strategies. Some studies have optimized drug dosage for cancer, achieving reduced toxicity and enhanced efficacy. However, data limitations hinder the generalizability of these models, emphasizing the need for pharmacohomogeneous insight and real-world data integration. While AI and ML hold potential for personalized cancer treatment, challenges like data availability, drug resistance, and real-world adaptability remain. Additionally, existing treatment methods are often too generalized, lacking personalized adjustment based on patient-specific characteristics. While existing studies have provided valuable insight, there are still key gaps. This leads us to the solution we are proposing in this research. As you can see on the slide, our research is divided into four major components, with each team member dedicated to a specific area of focus. This diagram illustrates the implementation flow of our research. Let's now turn our attention to the major challenges associated with this solution. Here we only consider breast and lung cancer patients for our research, and also only two side effects, nausea and neutropenia, are incorporated into personalization process. And also a clinical validation with oncology experts should be conducted before the real world use. Through our critical evaluation, we have discovered that the existing approaches to anti-cancer drug combination optimization often rely on single synergy metrics, oversimplified dose-response relationship, and lack personalization based on multi-omic patients' profile. To address these steps, we integrate multi-synergy scoring and personalized treatment strategies to enhance the accuracy and effectiveness of chemotherapy recommendation. Let's discuss future work of our research. Applying advanced techniques to refine feature selection and extraction, structuring them to initial draft to improve cancer classification, accuracy, and interpretability. And a hybrid model will be developed to integrate patient-level relationship and molecular interaction, enhancing classification accuracy and biological relevance in precision oncology. In addition, our efforts will be focused on building multi-synergy score, incorporating various synergy metrics and dosage information to improve anti-cancer drug combination predictions. Then the model will be designed to optimize chemotherapy recommendation by integrating...
This is a 1 minute gentle reminder.
Okay. Patient-specific clinical, genetic, and treatment history data while incorporating side effect profiling and adaptive treatment strategies. To wrap up, here are the key references that inform this study and supported our research. That concludes our presentation. Thank you so much.
Thank you so much. Are there any questions?
What are the findings? What are your basic findings?
Sir, this is still an ongoing research. So we are in the early stage of identifying key gaps and how to address these current limitations in current studies. So we are still, this is an ongoing research, sir.
Okay.
Thank you. Moving forward, I would like to invite Alavala Kavya to kindly present her paper titled Intelligent Traffic Management, Enhancing Emergency Vehicle Navigation.
Thank you.
Yes, Kavya. You may share your screen.
Yeah, 1 second. Is it visible?
Yes, it's visible. You may
Okay.
start.
Okay. A very warm good afternoon to everyone present. I'm Kavya Alawala, a final year undergraduate student from CMA College of Engineering and Technology, Telangana, India. I'm here to present a project titled Intelligent Traffic Management, Enhancing Emergency Vehicle Navigation. And authors of this project are me, Borra Shivaya, the faculty who have been guiding us through the project, and two of our college mates, Sai Kiran and Satvik. And these are the outlines of the presentation which I would like to discuss. And coming to the abstract, every second matters when it comes to emergency services. Whether it's ambulances, fire trucks, or police vehicles, delays can cost lives. The biggest hurdle here is the congested roads and inefficient traffic systems. Our proposed intelligent traffic management system uses real-time traffic data, AI models, and dynamic signal control to prioritize emergency vehicles while also reducing congestion for regular traffic. Now let's take a closer look at the problem. In India, cities like Hyderabad, peak hour traffic delays can go up to 45 minutes. Ambulances often take 20 to 30 minutes to reach patients, much higher than the ideal 10 to 15 minutes. This isn't just a local issue. By 2030, 70% of Indian population will be living in urban areas. That means smart, adaptive traffic systems are not only a luxury anymore, they are the necessity. This issue today is that emergency vehicles delays are often avoidable. Current traffic systems are static, don't adapt to the real-time conditions, and lack communication with emergency services. Coming to the research objectives, our goals are very clear and measurable. Build an ITM system for real-time emergency navigation, achieve at least a 20% reduction in emergency response times, reduce congestion and improve general traffic efficiency, and a framework suitable for large-scale deployment in India, and assess social and economic benefits of the system. Coming to the scope of the project, Coming to the scope of the paper, our paper is designed specially for urban Indian roads where traffic is unstructured and infrastructure is mixed. It may be integrated in future with the existing CCTV networks and is cost effective and can be expanded across cities using edge computing or cloud deployment. Coming to the literature review, in past several attempts have been made to address emergency vehicles prioritization using a variety of technologies, whether it may be RFID based systems or using ultrasonic sensors for siren based detection, which can trigger traffic light changes when a siren is heard, and drawback using the environmental noises and all, or the GPS based or GSM based context, which can be have a significant delay in dense traffic scenarios, and vision-based detection with older models like YOLO V3 or HAR Cascades. And based on the limitations of all these above projects, we decided to use YOLO V8, one of the most advanced and efficient learning models for object detection. Coming to the YOLO V8 architecture, the central component, which indicates both the backbone for future extraction and the detection head for prediction, image enters YOLO V8, features extracted by the backbone network, Darknet 5.3 or CSP Darknet 5.3. Features go to the detection head, which uses anchors for predictions. Bounding boxes and classes are created based on the features. Various losses are computed to train and improve the model. And this is the flowchart of the proposed system where the data has been collected from Kaggle Udacity, and the data has been pre-processed where the raw data is clean and transformed for consistency and quality, which includes resizing, normalization, removing noisy, etc. And features has been extracted by creating the boxes using YOLO V8, and data splitting which involves training set and testing set, and model training and model testing, and accuracy calculation using metrics such as accuracy, precision, recall, and F1 score, and ambulance detection output. And this closed loop process ensures the every ambulances get priority access with zero manual intervention. Coming to the experimental analysis, we have compared two models. A model MobileNet V2, lightweight but had difficulty detecting ambulance in dense scenes. And coming to YOLO V8, it is a real-time processing model which has high accuracy in low light, overlapping vehicles and chaotic scenes. Why YOLO V8? It gave us over 90% accuracy, minimal latency, scalability for edge or cloud deployment. These are some resultant discussions which we have done uh, with MobileNet V2 and our model, where our model has given us more accuracy, And these are some discussions with the other YOLO V8 models, where you can clearly see that our model has given less inference time and above 90% of precision. And this is the UI we have created to show up to which we have integrated with our model, and where there is a four-way introduction where you can upload the images, and which have we can also have the durations here. And to conclude, our system uses AI and real-time video to detect emergency vehicles. It creates a green corridor automatically using traffic signals overrides. It significantly reduces delays, saves lives, and improves traffic flow. It combines real-time object detection, dynamic traffic control, and automated prioritization. We believe this approach can lead to safer roads, smarter cities, and more lives saved. In future, we would like to integrate it with the real-time CCTV feds of traffic, and use data privacy and all. That's it from my side. Thank you, and I'm open for questions.
Thank you so much, Kavya. Are there any questions? All right. Since there are no questions, we'll be moving forward. Right. Moving next, I would like to invite Shrutika Jadhav to kindly present her paper titled IoT and Deep Learning Based Traffic Signal Control for Ambulances.
Yes,
Do
ma'am.
we have you here with us, Shrutika? Yes.
Yeah, ma'am. Am I audible?
Yes, you're audible. You may present your paper now. You are on mute. Yes, your screen is visible. Can you put it in presentation mode? Yes. You may start now. You're on mute, Shrutika. Like if you're speaking behind the screen.
Okay, am I audible now?
Yes, you're audible now.
Okay. I will present it again.
Yes.
Okay.
Yes, you may start.
Greetings, everyone. Today, I'm presenting our research titled as IoT and Deep Learning Based Traffic Control Signal Control for Ambulances. In urban areas, the traffic congestion significantly affects the emergency response time. This delay can cost lives, especially during the golden hour, the critical first 60 minutes after trauma. Hence, there is a vital need for intelligent, automated traffic control system that prioritizes emergency vehicles. The problems that we addressed is very simple and straightforward, yet critical. Ambulances often delayed by the traffic conjunctions. Traditional traffic management lacks the intelligence to prioritize emergency vehicles automatically, and according to the WHO report of 2023, 168,000 traffic deaths are reported in India, and which are worsened by the ambulance delay. So, the existing solutions that we currently have require manual intervention or specialized equipment inside the ambulance, which make it hard to scale and which are also not cost efficient. So, our goal is to create a smart, scalable, real time solution that minimizes the ambulance delay without expensive infrastructure changes. So, the objectives are to implement YOLO V8 for real-time ambulance detection, to automate the traffic signal, and to develop a Flask web application to monitor the traffic and detect logging the detection events. The framework contains YOLO V8 for ambulance detection, which detects the ambulance in real time. When an ambulance is detected, a Flask web application processes the signal and sends commands to the Arduino Uno, which dynamically controls the traffic signals and prioritizes the ambulance path. Importantly, this system requires no special hardware in the ambulance, which makes it cost effective. The methodology of our proposed solution. First of all, we start our feed by using an application IP webcam, which is processed by the YOLO V8. And when the ambulance is detected, the Flask web server sends a signal to the Arduino, which turns the signal green in path of the ambulance and other signals red. This system runs in real time and is fully automated to ensure efficient and uninterrupted emergency response. The implementation. So we have used custom dataset and some open source datasets. In model training, the YOLO V8 and hardware Arduino Uno and software Python, OpenCV and Flask. So our implementation, a smartphone with IP webcam, Arduino Uno, and we tested this in control setup, simulating a real intersection using LED lights to visualize signal change. This prototype closely mimics a real-world scenario using minimal cost-effective hardware. The results of our research. In our test, the YOLO V8 model showed high accuracy in ambulance detection. The entire signal switching process for detection to Arduino response just took 2 to 3 seconds. This helps. Importantly, the system functioned without any human involvement, providing its reliability in the real world. The future scope of this, looking ahead, we can extend the capabilities to include fire brigades, police cars, and VIP vehicles. We can also integrate it with a vehicle to infrastructure communication. And for future versions, this system could also use edge computing for faster processing. The traffic density based signal management can also be integrated to enhance overall traffic flow. So, in conclusion, our system presents a cost-effective and scalable approach to prioritize ambulances in urban traffic by leveraging existing infrastructure like traffic surveillance cameras and basic hardware like Arduino. The solution avoids the cost of GPS trackers or RFID tags. Most importantly, it operates autonomously, reducing ambulance delay and potentially saving lives. This research contributes significantly to the vision of AI-powered smart cities and efficient emergency response system. Thank you. This is from my side. Do you have any questions?
Thank you, Shrutika. Are there any questions? Since there are no questions, we'll be moving forward.
Thank you.
Thank you so much. Moving up, I would like to invite Syed Hassan Murad to kindly present his paper titled Performance Analysis of Electrical Properties of CMTS Solar Cell Using 3D Simulations. Do we have you here with us, Syed?
Yes, ma'am, I am here. Can you hear me?
Yes, I can hear you. Just a second. Yes, you may present your screen.
Okay, ma'am. Ma'am, is it visible?
Just a second. Yes, it's visible. Can you put it in presentation mode? Yes, you may start.
Okay, ma'am. Good morning, everyone. Sorry, good afternoon, everyone. My name is Syed Hassan Murad. I'm from AIUB, the master's students from Triple Department. I am pleased to present our research title, Performance Analysis of Electrical Properties of CMTH Solar Cell Using 3D Simulations. This work was conducted in collaborations with AIB and Bangladesh Council of Scientific and Industrial Research. Here is a quick overview of what will cover in these presentations. We will begin with an introductions and the objectives of our research, followed by the background, methodology, results, and finally our conclusions. I will also happy to take questions at the end. With the global push for sustainable energy, solar technology has become more important than ever. CMT's thin film solar cell, known for their cost effectiveness, environmental friendliness, and ideal bandgap, are emerging as a strong candidate. In this study, we used 3D console simulations and integrated tin sulfate as a back surface field and cadmium sulfate as an electron transport layer, achieving a promising efficiency of 38%. The goal of our research was therefore to develop a robust 3D simulations modeling for CMT's thin film solar cell using COMSOL multiphysics to evaluate the impact of corresponding tin sulfate and cadmium sulfate layer on device performance, and to analyze the key electrical properties to enhance power conversion efficiency and minimize the recombination losses. Here is the background of the research. Before diving into the result, let's review some important context. We will look at the properties of CMTAs as observer, advancement in this area, the role of tin sulfide as a back surface field, and the increasing use of simulations in solar cell development. Here is the background of CMTS. CMTS or copper manganese tin sulfide is a promising alternative of CZTS, which is widely used in thin film solar cell. While CZTS is eco-friendly and cost-effective, but it suffers from high defect density and stability issues. By replacing zinc oxide with the manganese, CMTS reduces these defects, offer better structural stability, and maintain an ideal bandgap of 1.5 electron volt, perfect for solar absorption. In short, CMTS combines the benefits of CZTH with improved electrical performance, making it a strong candidate for the next generation solar technologies. Overview of CMTAs as an absorber material. CMTAs or copper manganese tin sulfate stands due to their affordability and lack of toxic elements like cadmium sulfide. It's well suited for solar absorption. Recent advancements shows that the integrating tin sulfate and cadmium sulfate can push power conversion efficiency to over 31%. Tin sulfate plays a critical role in enhancing open circuit voltage and facilitating hole transport while minimizing electron leakage. However, there is a lack of detailed studies on how tin sulfide affects carrier dynamics. Our research uses 3D simulations and fill this gap by analyzing charge transfer, and recombination mechanisms. Simulations tools are crucial in solar cell development. We used SCAPS 1D for our previous research, but in this research, we use COMSOL multiphysics for a comprehensive 3D look at electrical behavior. Here is an overview of our simulation workflow. We built and analyzed a 3D model of CMTS thin film solar cell in COMSOL with a focus of understanding the electrical characteristics, understand operating condition. Our horizontal configurations consist of multiple layers: copper, zinc oxide, intrinsic zinc oxide, cadmium sulfate, CMTS, tin sulfate, and the platinum. Each layer has a specific function. Zinc oxide and the intrinsic zinc oxide are transparent conductor. Cadmium sulfate acts as a buffer. CMTS is observer, and tin sulfate serves both as the back surface field and the whole transport layer. The simulation was run under standard AM 1.5G irradiations at 300 Kelvin temperature. To ensure, we use sweep meshing with element size ranging from 52 nanometer down to 2.24 nanometer. High resolution meshing interfacing was especially important for capturing precise electrical behavior. Let's move on our results. This is the GFE characteristics, shows how CMTS solar cells perform under illuminations. The results highlights improved current density and voltage due to integration of tin sulfates and cadmium sulfates layer. This curve represents the power output under operational conditions. We clearly observe the peak power point from which we can calculate the power conversion efficiency at an impressive 38%. Here is the power conversion efficiency calculation. This is the electric field distributions. Here we see the electric field is strong at cadmium sulfate and the CMTS interference, aiding interference, charge separations, and reducing the recombinations. These plots show the donor and acceptor concentrations in device. Analyzing these concentrations helps us understanding the internal electrical field formations and the junction quality. Compared to the previous work, our integrated model achieved a significant improvement in the power conversion efficiency. This validates the effectiveness of combining tin sulfate and the cadmium sulfate and using the 3D simulations for more accurate analysis. To summarize, we achieved a power conversion efficiency of 38% using tin sulfate as the back surface field and cadmium sulfate as the electron transport layer. Our 3D simulations provide new insights into the electrical behavior. This is the first study to offer a 3D coupled electrical analysis of CMTI solar cell. In future, we aim to explore non-toxic buffer materials like zirconium disulfide and investigate the better thermal management techniques. Here is the reference we are required during our research. Thank you all of you for your attention. I would like to answer any questions you may have.
Thank you so much, Syed, for presenting the paper. Are there any questions?
What is the efficiency of the solar cell?
So we got the efficiency 38%.
So this is very less, isn't it?
No, sorry, it's very high almost. Generally, the CMTS solar cell in recent practical use in practical device CMTS efficiency we got more than 31%, not above 33.
Okay.
In practical scenario, it's 32, the highest efficiency.
Okay.
Thank you, sir.
Thank you so much. Moving forward, I would like to invite Sunil Kumar to kindly present his paper titled Predicting Dyslexia with an Ensemble-based ML Technique. Do we have you here with us, Sunil? Is anyone from the team present? Since no one is there, we will be moving forward. I request Gopi Krishna to kindly present his paper titled Quantifying Ethical Integrity in AI, a framework for ethical impact scoring in data annotation. Do we have you here with us?
Yes, I'm there. Can you hear me?
Yes, I can hear you.
Thanks.
Yes, you may present your screen.
I hope my screen is visible.
Yes, your screen is visible.
Yeah, thanks. So, good evening, folks. So, today I'm going to present some of an interesting topic on this ethical integrity in the AI models that is being developed and being used by all the model companies, AI model introduction companies. So, when I say ethical models, I just want to give a brief introduction before a deep dive into this ethical integrity in the AI models. So soon, AI systems will increasingly start interact with our in our day-to-day lives. They already have started, but in a course of around 5 to 10 years, the interaction will be more actually. For imagine that you have a humanoid in your system, in your house, in your office, in the on the road, on the public places. So some of the humanoids at your home can be helping your father or mother when they get older. They may be helping your children's actually in the future. So when we arrive at that particular stage of life in 5 to 10 years or maybe sometime, so there should be a lot of ethical and responsible integrity that we want to provide to those models which were deployed inside those humanoids. So a lot of humanoid systems were started developed by top tech companies in US, and my primary concern is how ethically they should be cooperative and working along with the human beings. So the root cause of many ethical failures, there are a lot of ethical failures which are happening with the AI models, mainly the biased training data. So if the training data is not if there is no quality in the training data, if we are not pinpointing each and every detail in the training data, then the AI models will start behaving erratically. So some of the current challenges is bias in the training data. That's number one. Second thing is lack of cultural diversity and representation. For example, a model which is developed in US, if they are being deployed in Saudi Arabia, in some other countries, Middle East countries, and imagine what if they violate some of the cultural diversity and representation diversity, which was being followed for a long time in that particular country. So the AI model should be culturally trained, and representation also should be present actually. So they should not when I say representation, the representation is nothing but they should be able to cater to the entire world community. And about the opaqueness in the annotation process. So we don't know. See, a lot of training data sets are now being synthetically being generated by AI models. They are not being annotated by the humans. So that's also a primary concern. There's a opaque annotation process with the data set. So and what the real world consequences? Some of the models which failed very badly in facial recognition systems, in loan approval systems. For example, in approving when some of the top banks in the world, they employed AI for approving the loans, they failed miserably because of bias in the training data set for the minority community. If a person from minority community, if he applies for a bank loan, see, most of the data for those systems, loan approval AI systems, they were trained only with the majority community, not from the minority community. So, of course, the probability itself is very less for approving a loan from the minority community. So, these kind of real world consequences are also being faced by many of these users of the AI models. And 35% of the ethical issues, and they originate from the data collection and annotation stage. There are 4 or 5 stages in this AI lifecycle management, and first step is the data collection. Second is the annotation, means the labeling of the data, and third is the model development. Fourth is the training and validation, and the fifth is the deployment and the CI/CD pipelines actually. So of among all these 5 different stages of AI lifecycle management, the 35% of the importance on this ethical issues, if we control this first step and the second step, that is the data collection and the annotation stage labeling part, they contribute around 35% of these ethical issues, is what is being analyzed and proposed in some of the papers. So what can be the solution for this kind of ethical issues inside the AI models? What can be? So the data set that we use for training the particular model, AML model, that should be having a score actually that called as a ethical impact score. So for example, a particular model, for example, take Llama or OpenAI ChatGPT or whatever model that you take, all those models are heavily trained by the data sets, and each data set they will be uploaded inside the model for training purpose in phase by phase manner, stage 1, stage 2, stage 3, a lot of the stages will be there. So for each of those stages, the data sets, we need to provide some scores that is called as the ethical impact score. That's not being stringently followed by some of these organizations, but we need to introduce this particular framework to this score. That's what is the proposal. So the formula for that particular ethical impact score is W1 star offensive content, whether the data is containing any offensive data content, or W2. I will come back to W1, W2, W3, W4 in the following slides. So first, this score should be a composition of offensive content, cultural sensitivity content, diversity content, and representation content. Offensive content is, for example, in the data which is being sent to the AI model for training purpose, does it contains any offensive pictures or images or audios or something like that, or cultural content, or diversity part which I mentioned, and representation, male, female, and gender things actually. So diversity part comes with more of country and geographic specific. Cultural specific is more of the region specific data also should be present, and there should not be any bias in this particular data. So this is the formula that we propose, and some of the components how this particular EIS ethical impact score for a particular data set will work is, for the offensive content, if for example in one particular data set, if we have 500 data units, and out of the 500 data units, out of the 50 data units are categorized by the human annotators as offensive, then the score for this particular, the first component, offensive content component, should be 0.9. And coming to the second component, the cultural sensitivity, how does it work? Out of the 500 data set units, the data units inside the data set, if 40 were flagged as culturally sensitive by the human annotators, then the score of the data set should be, for that particular component, should be 0.92. Coming similarly, diversity, using Shannon diversity, that we arrive at a score for the diversity contribution as well as the representation contribution. These are the formulas, simple formulas actually. So combining all these things, we arrive at a ethical impact score. Here example is given for 500 units inside a data set, and we are assigning a weight of 0.4, 0.3, 0.2, 0.1. Again, I will come back on how we are assigning this particular weight, and with this particular weights, we have arrived at the EIS ethical impact score of 0.846 for this particular data set, which was used for training a particular model. And again, coming to the interpretation, if this particular score lies between, for example, this particular score lies between 0.846 and this lies in the second moderate ethical quality score. And like this, we have to categorize each and every data set with which the AI model is trained as strong ethical integrity or moderate ethical integrity or ethical concerns present or high ethical risk. So with this, we can classify the data set which we use for training the particular model actually. So, and how these weights are being arrived, now comes as the main picture. So mainly these weights should be assigned by the ethical impact AI governance actually. For in Europe we have EU Act, in India also we have this India AI Act is drafted and published recently before 3 or 4 months, and California AI Act. So region specific AI government should specify these weights actually, this 0.4, 0.2, how much of weight that they need to assign for these different components. For cultural, for example, in India, for a specific community, if we are going to deploy a AI model, then the government should specify the cultural sensitivity of this particular data set should be 0.9, and diversity should be 0.5 or something like that. The AI governments, they need to regulate this particular framework, and sometimes it can come from the customers itself. For example, if Amazon is going to deploy AI model in some specific parts of the world, and Amazon can, with the recommendation from that particular country as well as from the various AI acts, Amazon can propose a particular weight. Or the data annotation companies, for example, there are a lot of data annotation companies which are helping this AI model building organizations like Microsoft, Cloud, or OpenAI. The data annotation companies which are helping these organizations are nothing but Scale AI, Surge AI, Appen AI. So some of these data annotation companies, they are helping the models to learn, actually, to train
This is
actually.
a gentle 1 minute reminder.
Fine. Thanks, Priyanshi. Yeah, and also it can be a collaborative approach between these AI governances and the organization's customer providing the data or the AML model delivering companies. So through them, we can arrive at the weights for this particular formula. Okay, so how it can be implemented? This can be implemented with the AI regulatory bodies, number one, and some of the pilot projects also need to run for testing this in specific domains like healthcare, finance, and supply chain, a lot of things. And observing this, we can expand this to multiple audits. And in conclusion, when we are nearing this, see, this particular EAS will be a quantifiable approach. Currently, we don't have any approach, a quantifiable approach for this data set, which we use for training the AML models. So using this approach, we can focus on the quantifiable manner we can train the data sets. And if the data set is not with a good score, then we can reject that particular data set in training the AML models. So also it supports the compliance with the emerging regulations. That's soon we will be facing the heat on this third point from various countries, and it promotes some of the transparency as well with what data that we have trained any particular AI model, and ultimately it contributes more to the responsible AI of the future. Yep. That's it from my side. Yep. Thank you, everyone.
Thank you so much, Gopi Krishna. Are there any questions? Since there are no questions, we will be moving forward. Right. I think Sriram missed the presentation earlier. I would again like to invite Sriram Suresh to kindly present the paper titled Early Detection of Parkinson's Disease Using Machine Learning, a Comparative Study of Multimodal Data Integration. Do we have you here with us, Sriram?
Yeah, ma'am. Can you hear me, ma'am?
Yes, I can hear you. Would you like to present?
Yeah, ma'am. Yeah, ma'am.
All right. Please go ahead.
Can you see my screen, ma'am?
Yes, your screen is visible. You may start.
Okay, ma'am. So good afternoon to all our present here. This paper is about a reduction of Parkinson's disease, a neural-based disease. So I just want to say how the presentation flows. It contains this introduction, motivation, literature survey, and other stuff that are important to discuss about our research. So introduction, I want to briefly discuss about what is Parkinson's disease actually means. It's a neurodegenerative disorder which actually comes because of improper function of brain, which results in improper functions of our muscles and reduction in movements, and our motor neurons get damaged. So in our research, we found that detecting this Parkinson's disease in an early stage will help us to recover and cure it more efficiently. So like what's the main motivation is to detect the Parkinson in earlier stage so that it will be helpful in treating and curing the disease and maintaining the model efficiency. Utilizing gradient boosting machines like XGBoost is a most efficient model in finding through these data sets actually. Then these are like literature surveys that we went around. We took around 6 papers and found what are the methods they were thinking or how they were processing. Then found what are the inference in those papers, found the drawbacks that they missed, and we plan to solve those issues in making our project more useful. Then the main problem statement is like Parkinson's disease is a progressive neurodegenerative disorder impacting both movement, speech, and cognition. Early diagnosis is so vital, so that we are planning to make this more important in curing this disease in so early stages. So main objective is to develop a early detection model and to make the efficiency of the model more powerful. So the project flows in this way, like first we want to collect the data and pre-process it, make it more efficient. Then we select the features from it, split the data into training and testing so that it will be efficient for the model to find. Then we train the model and we evaluate the model to get the final results. So what the data set that we use is like we got the data set from Adrio de Oliveira, Andred and Joao Paulo Flora from the NIATS of Federal University, which has more collection of data from the patients who are in the local. So that we splitted the data into 70:30 ratios. Our data set contains 193 samples, each with 24 variables in it. Our main intent to detect motor dysfunctions through handwriting analysis. This dataset offers a wide array of features vital for early identification of Parkinson's disease. The pre-processing step is more vital so that we can remove all the unwanted values from the dataset so that the model won't be get confused and model get trained efficiently. For vocal features, parameters like pitch variation, jitter, and shimmer are extracted, while for motor features derived from handwriting patterns, waveforms, and spiral drawings to identify indicators of motor dysfunctions. The pre-processing involved detecting and handling of null values, duplicates, and eliminating outliers so that the dataset becomes more accurate. So these were the results that we obtained after pre-processing. First, we found that there were many duplicate entries in the dataset. So we plan to remove it and we make sure that there is no duplicate entries in our dataset. Then missing values. Missing values is one of the major concern. So we plan to find where are the missing values and how we can eliminate that. After pre-processing, we eliminated the missing values and cleared the dataset is pure. Then these are all the models that we trained. Our main objective is to compare 3 different models through a common data set and found that which model is better and which gives accurate information. And model we use are K and K nearest neighbor is a method that classifies a new data point based on categories of its closest K neighbors from a training data set. To do this algorithm, we calculate distance between the new data point and each sample in the training set, and we use the predefined formula in it. And this rough diagram how it works. Then our second algorithm is random forest architecture. In random forest, a method of ensemble learning commonly used for classification and regression tasks. The training phase, this approach builds multiple decision tree by randomly selecting subsets of training data and choosing features at each split. And we have a predefined set of formula for this too. Then our main model is XGBoost architecture. XGBoost is extreme gradient boosting, is a sophisticated machine learning model that utilizes gradient boosting to build decision tree in an iterative manner. In this approach, every new tree is created to address this mistake made by previous trees. To prevent overfitting and ensure robust model performance, XGBoost incorporate through lasso and regularization. This overfitting is one of the most common issues, so we plan to reduce those overfitting by using this algorithm. Then we must have a predefined performance matrix through which we consider the model is performing good. For that, we used 4 parameters, which is accuracy, precision, recall, and F1 score. This accuracy helps in detecting how accurate the model is, while precision, recall, and F1 score are other things that help us in deciding whether the model is robust or the data set is fine, how the model runs along the data set. These calculations are done with these 3 remaining performance matrices. So these are the results that we obtained. So basically we have 2 data sets for comparison. One is a voice feature data set through which the subject's voice are recorded, and based on their values, models run along those data set. And there is another data set which are subjects are made to draw some wave patterns or spiral drawings in a rough paper and made as pictures, and those pictures are also collected as dataset and run along it. But comparing this voice feature dataset and wave pattern dataset, we concluded that voice feature dataset gives a more accurate detail that whether the person is infected with Parkinson or not. So in taking a particular dataset, then we want to finalize which model is so good in acting along it. So we found that XGBoost algorithm is performing more accurate in comparing other 2 models. We got an accuracy of 88% in voice dataset, while in handwritten we won't get that nearer accuracy. So we conclude voice feature is more accurate. Then For another one clarification to make our model is more accurate, we used cross-validation. K-fold cross-validation is reliable and highly effective evaluation technique widely employed in machine learning for model assessment and selection. This method involves partition the dataset in 10 equal subsize or folds and systematically alternating between training and validation phases. This approach ensures a thorough evaluation of model performance. So we cannot just conclude model just by comparing through data sets. So we found that using a cross-validation technique would help us to conclude that this model is so better than performing other two models. Then I would like to conclude my presentation with what we found through the research. This study emphasized the capability of machine learning techniques in the initial detection of Parkinson's disease by integration data from different modalities, by combining vocal features such as pitch, jitter, and shimmer with motor characteristics obtained from handwriting evaluations. And the algorithms that we used are KNN, random forest, and XGBoost. Finding of our experiment indicated that XGBoost exhibited superior performance relative to other models, attaining an accuracy of 88% of the vocal dataset. This outcome underscores the capability of XGBoost to manage and potential disabilities inherent in datasets that integrate a variety of Parkinson's disease associated features. Then these are the reference paper that we gone through to make sure our research work is better.
Thank you, Sriram.
Thank you, ma'am.
Are there any questions? All right, since there are no more questions, we'll be moving forward.
Okay.
This is the last call to invite Sunil Kumar to present his paper titled Predicting Dyslexia with an Ensemble-Based ML Technique. Do we have you here with us, Sunil?
Yes, ma'am. I will be presenting my paper. Just a second.
All right. Yes, your screen is visible.
Screen is visible, madam. Okay, just a second, madam. Let me adjust it with the screen and I would work. So here I'm presenting my paper that is predicting dyslexia with an ensemble-based ML techniques, and it's a neurological disorder that is dyslexia has a global impact that millions of children with the sloppy word comprehension and support reading abilities, which causes the effect. So, what is dyslexia? Dyslexia is a neurological disorder that is characterized by words generally poor reading performance and children's and adults. Therefore, different major differences like verbal working memory and speed of communication. These difficult typically result developing of phonological competence and language, often unexpected relation to other cognitive abilities. It makes more insociable for the person who have dyslexia. So you can see an example that how people with the dyslexia will receive the perceive the paragraph, and this is original paragraph. What actually they have difficulty presenting the things. And symptoms of dyslexia here, sign of dyslexia can difficult to recognize. It actually before they entering to the school, we need to recognize it. The symptoms which causes delayed early language development and problem recognizing the difference between the symbol sound and segments that T they can't recognize it. Difficult with learning, reading, and writing specific skills. So people with dyslexia are beginner readers and make longer fixations and shorter scan and more regression readers without dyslexia. Inability of sound pronunciation and fluence or sloppy word comprehension. So diagnosis of child development. This includes factors like we need to know that family history, medical history of the kid or any adult. That even we need to know that child's home life. Doctors will attempt to understand the child has an issue, so it could affect their learning. Use of questionnaires. These will use normally we have different kind of things, and also need to diagnose with the vision, hearing, and neurological testing, such as is very useful for the identifying whether children have another identifiable cause, and psychological testing that is done by the doctors. Mostly we will be seeing that so this channel like that we use it to calculate all those things, and a child may undergo reading and other skill test, and game field test also can be done. It's why dyslexia is a serious issue. That it is a serious issue. That is the thing that social problems that dyslexia not treated properly, that causes anxiety, depression, all these things will happen. And even it makes inability to read and write. So that is difficult for the any kid or any kid to learn other things. And children have dyslexia can having they have hyperactivity disorders and vice versa. They can they can't keep attend. They will be have less attention. So dyslexia, so it has dyslexia prevention, that is challenges that dyslexia affects 10% of population, causing reading difficulties. It is early detection is difficult and critical effective intervention, especially diagnosis methods. We have reading, writing, Gamifield test, and MRI, EEG. All detection remains challenging, and so we are proposing machine learning for ML offers improve accuracy for dyslexia detection, analyzing complex data patterns. There is a gap in ML approaches. So we are going for ensemble. It's a subset of ML that combines multiple models. So stacked, it creates a stacked model for better accuracy and robustness prediction. So key ML steps that we are much aware: data collection, pre-processing, feature extraction, and model training. And we don't have effective dyslexia classification model. Here we are focusing, that is research literature highlights the dyslexia detects but challenge implementation model of prevention. So ML dyslexia detection, that is data collection, that is traditional methods, Glenna and behavioral tests, that is reading, writing, and memory assessments. It's a time-consuming thing, and ML-based approaches also have a diverse data based on text, eye movement, MRI, EEG scans, and handwriting and game field interface. So the challenges related to is language dependency and costly lab equipment like EEG, MRI, and potential participant discomfort. Solution: so better solution is that we create an app, that Gamifield app or something else. We need to create language dependent game test to improve scalability and accessibility. So pre-processing in processing, that is raw data EEG, that has to be converted into quantity or qualitative formats, and we need to use low pass filter, high pass filter, will transform to manual filtering, and all those things needed. So those things mainly used to remove noise and extract relevant features and reduce the complication. So next is feature selection. It is a critical step to identify more discriminated features, and that methods include manual selection, lasso, and SVM RFE, and model training and classifying and data splitting need to be done. Those things we need to use. We are using that LOCV and 70-30 split, and most algorithms are SVM most popular, and logistic regression, neural networks, and KN and LDA. So in this, that SVM excels high dimension sparse data, but struggles with the noise. So we need to covariate analysis multiple models in order to ensemble methods better accuracy. So this is our model. We are making use of a data set that has 196 features of 3000 portions, and it is trained with the different basic models, SVM, KNN, RFN, and it does the multiple prediction, and again we create a trained data set and we compare with the logistic regression, and we will go for the final prediction. So this diagram outlines classification pipeline using the data with 4 algorithms, that is SVM, KNN, and random forest and logistic regression. And this process involves multiple prediction stages and completing final prediction. That is a stacked model. Notably, it's active windows that appears an unrelated system. It can be degraded. So this workflow highlights the multi-model approach for dyslexia detection and potential ensemble integration for the accuracy, better accuracy. So it combines ML models, as I said, improve accuracy and robustness and generalization, and techniques with the bagging, boosting, and stacking, and random forest. So now, we have baseline model is random forest and logistic regression, SVM, KNN, and stack model. So here we address the heterogeneous lack of ensemble model for the heterogeneous dyslexia data sets and limit users specialized detection. So this is the result we found. That is the data set used here is the study of consisting of 196 features for the each participant of 3000, and that is going to have 4 features being will be, that is gender as well as native of the language, and also their age, and 5 to remaining the 4, these are the 4 features, and 5 to 196 feature will be performance based with the questions, and we'll be asking 32 questions in it. So based on that, the data set is created. Then we go for the finding the data sets processing. We found accuracy and precision as well as AU, ROC. And in that, we have LR achieved the highest accuracy of 89 point, that is logistic regression, which achieved 89.5. And when we go for the recall and specificity of the comparison of different models, LR achieves the highest accuracy, and followed by the closely accuracy, which is KN and RF achieved 87.4 and 87.95, where SVM was SVM, which has accuracy of 86.58. So beyond that, when we go for stacking the combining all things and making use of baseline model, the stacked model, which achieved almost 91.3% accuracy. So beyond this, we have also calculated the figures from here on. We calculated the ROC curve for the individual machine models like LR, RF, and SVM, and Canon, even Canon also, which are shown here. So you can see achieves highest area AEC values for the LR, and also you can see all the models like SVM, all these things. So ROC for the models with the stock model, without stock model, and KNN models ROC, and ROC for all models. And this is the comparison precision versus recall, and ROC models with the stack models, and true positive rate and false positive rate, and more area under ROC or better models, and stack model using a higher AU ROC for the random forest, you can see. So these are the models. So the study results the strong performance across the multiple classification algorithms for dyslexia detection, and with that LR achieves the highest accuracy. And when you go for the other models like RF and KNR, which are near to the RF model, but SVM also performed with the accuracy of 86.58. But the ensemble model combining prediction of LR, KN, and RF SVM, and all these outperformed, and with the accuracy of 91.5% accuracy. So ensemble method enhanced the predicting performance of the dyslexia calculation. So this research highlights the effectiveness of both individual as well as the stock model accurately identifying the dyslexia, with the ensemble learning offering the most robust solution. So ensemble model, which gives the highest accuracy compared to the all basic models, and this is how our research went on, and we have presented the results for this. Thank you.
Thank you so much, Sunil, for the wonderful presentation. Do we have any questions?
Sunil, have you tried LTST for this?
No, sir, we haven't tried.
Okay.
Any other questions? All right. With that, we have come to the conclusion of this session. Yes. I sincerely thank all the authors for their excellent presentations and contribution in this session, and all our participants for being a part of this international conference. I hope this session was informative enough. We, on behalf of the whole team, thank you for the support during this 9th version and all the previous 8 versions of the conference. We'll be happy to have you in the 10th version in 2026 as well. All the presenters would be getting their digital certificates through email within 2 working days. Further, all the papers have already been forwarded to the Springer. The publication will be live within 6 months. Kindly cooperate with the team of ICTIS 2025. I also thank our session chair, Dr. Vishwajit Thakur, for chairing this session. Here's a small token of appreciation on behalf of ICTIS team and Global Knowledge Research Foundation. And yes, I would like to take the closing remarks from Sir.
So all the papers presented were very good, and they represented a state of art in the field of AI, machine learning, photocells, and many other things. So I am really happy to share that all the presenter had made a good presentation. The first presentation was on operating system, was just of undergraduate level. It was a comparative level basically. Rest all were of a research kind of presentation. So yeah, it was really good. Technically, all AI machine learning papers were very good, and I hope that you will get a good papers and good research in the future. Thank you.
Thank you so much, sir. Thank you so much
Thank
for
you,
your
sir.
kind words. and thank you everyone for your valuable presence. Before ending the meeting, I would like everyone to turn on their cameras for a quick snapshot. Right. All right. 1, 2, 3. Thank you so much, everyone. Have a good day ahead.